Hello pre-cal students. We're today looking at 15-3, law of cosines. So right off the bat they're giving you the formula for law of cosines. And once again, law of cosines gives another relationship between sides and angles in any triangle, like the law of sines. So previously, when we're doing SOHCAHTOA, something like that, we have to have a right triangle. With law of sines and law of cosines, we can use any triangle. It can be obtuse, it can be acute, it can be a right triangle. Any triangle, these things are going to work from. What you might notice is here's our first form of the law of cosines. C squared equals A squared plus B squared minus 2AB cosine C. All right, it looks, if I take off the back term here, it looks exactly like Pythagorean theorem. So it's kind of a modified version of the Pythagorean theorem here. Or we can solve for the angle. So that's if you're looking for a side, C, or if you're looking for an angle, C. Cosine C is equal to A squared plus B squared minus C squared over 2AB. Okay? And once again, we're going to do a little proof, a little derivation to show where this comes from. Let triangle ABC be any triangle. Notice we have angles A, B, and C here. Across from A is side A. Across from C is side C. Across from B is side B. But side B has been split up because we've drawn an altitude from angle B to the opposite sides. That's our height, h of the altitude. And then we have b minus x to the left and x to the right. Notice if I add those together, b minus x plus x, the x's will cancel out. My answer would be b. Okay? All right. So here's the deal. We're going to derive the first version of the law of cosines here. So I'm going to start with the Pythagorean theorem on the left side here. So I've got a right triangle if I consider the height here and then these other two sides. So c squared, the hypotenuse squared, equals b minus x squared, this side squared, plus h squared. Alright, so that's the Pythagorean theorem. If I expand b minus x squared, I get b squared minus 2bx plus x squared plus h squared. Alright, now what you might notice here is that this part right here, this x squared plus h squared, is actually equal to a squared using the Pythagorean theorem on the right side. But the hypotenuse a squared is equal to x squared plus h squared. So I can replace x squared plus h squared with a squared. Alright? Now, I basically want to get rid of this x here. So, just put it out here to the side to replace x. What I'm going to do, I know that cosine C is equal to the adjacent x over the hypotenuse a, x over a. So x, if I multiply both sides times a here, my a's will cancel, and I get x is equal to a cosine C. So I'm going to replace the x here with a cosine C, and I'm also going to do a little rearranging. So I'm going to put a squared first, a squared, a positive b squared, minus 2b times x, which is a cosine C. And now I'm just going to rearrange just a little bit more here. A squared plus b squared minus 2, I'm going to put a in front of the b here, 2ab cosine C, and that is our law of cosines. Okay? Now, notice I could have put these letters, I could have changed the a here to a b, and changed this to an a or c. I could put these letters in any order I want. So it would be true that not only c squared equals a squared plus b squared minus 2ab cosine C, but also b squared will equal a squared plus c squared minus 2. Notice the two letters here match the two letters here. So 2ac cosine, and this angle has to be the same as this over here. So cosine capital B, or a squared equals b squared plus c squared minus 2. The two letters have to match these, BC. Cosine of the angle that matches this, so angle A. So there are all three that we might have here. For version 2, this up here, looking for the angle, cosine C equals a squared plus b squared minus c squared over 2ab. I'm going to start with the formula we just found. C squared equals A squared plus B squared minus 2AB cosine C. And we're simply going to solve for cosine C. So the first thing I'm going to do is, since this whole term is a negative, I'm going to add it over to the left. So positive 2AB cosine C. And I'm going to go on and subtract that C squared from both sides as well. Alright, so these are canceling, these are canceling. I've got 2AB cosine C equals A squared plus B squared minus C squared. And finally, to get the cosine C by itself, I'm going to divide both sides by 2AB. And there's version 2. Cosine C is equal to A squared plus B squared minus C squared over 2AB. There's version 2 of the law of cosines if I'm looking for an angle. All right. Once again, the order of the letters is not important. So we could say cosine A. All right. If my angle is A, then the first two have to be the other two sides. B squared plus C squared minus little a squared. Just like here cosine C, and I have minus C squared over 2 times these first two letters here, BC. Or I could say cosine B equals A squared plus C squared minus little b squared all over 2AC. Oops, sorry about that. All right. So I'm sure some of you are thinking to yourself, or maybe even saying out loud, but Mr. Thornton, when can we use this? All right, so law of cosines can be used to solve triangle problems where we know two sides and the included angle of a triangle, or we know all three sides. We don't know any angles, but we know all three sides. Okay? So when we say two sides and the included angle, if I have a triangle, if I know this side and I know this side, the included angle would be the angle between those two sides. All right? If I have a different triangle here, now let's say I know this side and this side, then the included angle would be the one between those two sides. Okay? So included angle means between the two sides that are known. All right, so this first one says triangle ABC with angle B is equal to 35 degrees. A is 5, C is 6. So this is let's draw this out. And again, I'm just going to kind of draw a generic triangle here. Doesn't really matter what it looks like. ABC. I know B is 35 degrees. I know little a is 5. I know little c is 6. So what I have is two sides in the included angle. Okay? So what I have to do is solve for little b. I have no choice here. That's all I can do. So I'm going to use b squared equals a squared plus c squared minus 2ac cosine capital B. So let's just plug everything in. B squared equals my little a is 5, 5 squared. My little c is 6, 6 squared. Minus 2 times 5 times 6, same numbers. Cosine 35 degrees. Remember that we are using, make sure your mode is degrees when you're doing these. Alright, so b squared, if you put this in the calculator, b squared comes out to be about 11.851. And then we take the square root of that. It's going to be the positive root since we're talking about the length of a side. And so b is approximately 3.443. Okay? All right, let's try the next one. Okay, I've got three sides here. A is 10, B is 5, C is 6. It says find angle A. So once again, draw my triangle A, B, C. Little a is 10, little b is 5, little c is 6. And I'm looking for angle A. So we're going to use cosine of A is equal to b squared plus c squared minus a squared over 2bc. So b squared, that would be 5 squared, plus c squared is 6 squared, minus 10 squared, over 2 times 5 times 6. All right. Just putting the top in the calculator, I get negative 39. Putting the bottom in the calculator, I get 60. So angle A is going to be the inverse cosine of negative 39 over 60. We're going to round that to 1 decimal. And so that is about 130.5 degrees. So angle A is an obtuse angle, 130.5 degrees. Notice it is the longest side, so it is possible that that angle is going to be, that angle has to be the biggest of the three, and it is possible it might be obtuse. Which brings up our next thing we're going to talk about. Okay, so on the next page we have this important note. The law of cosines and the law of sines can both be used to solve non-right triangles. However, here's a big deal. We like to use law of sines when we can because it is much simpler. It's easy. Law of sines, you know, sine of A over little a, sine of B over little b, sine of C over little c. It's easy. Law of cosines, a little more work. So I prefer law of sines if I can use it. However, law of sines cannot distinguish between acute and obtuse angles, because both first quadrant acute and second quadrant obtuse angles have positive ratios. Remember, sine is positive in both the first and second quadrants, and so you can have two different angles get the exact same sine values. All right, I could have an angle, for example, pi 6 and 5 pi 6. They have the exact same sine values, okay? Law of cosines is not that way because it's positive in the first quadrant. Cosines are positive in the first quadrant, but they're negative in the second quadrant. So they can distinguish between acute and obtuse angles because first quadrant acute angle has a positive ratio for cosine. Second quadrant angle is going to have a negative ratio. Okay? So when solving for the angle, if we're looking for the angle, if we're given three sides, we're looking for the angle, or anytime we're looking for an angle. If we have two angles we're looking for, if there is any possibility that the angle you are solving for is obtuse, which would have to be the biggest angle of the three, do not use law of sines. Okay? Alright, so if you have a choice and you want to use law of sines, find the smallest angle. Alright? Remember that the largest angle in a triangle will always be located opposite the longest side. Okay. So let's put that into practice here with number 3. Triangle has sides of lengths 15, 6, and an angle of 50 degrees. So let's draw this out. Ooh, that was not a very good triangle. Alright, A is 50 degrees, I've got B is 15, and C is 6. I've got to use law of cosines to find the other side. I have no choice here. I'm going to find A using law of cosines. So A squared is equal to B squared plus C squared minus 2BC cosine of angle A. So let's plug in our numbers. A squared is equal to 15 squared plus 6 squared minus 2 times 15 times 6 cosine 50 degrees. Okay? Alright, if I plug all that into my calculator, I'm going to get that this is roughly, A squared is roughly 145.298. And clearly that cannot be that side, so be sure you take the square root. Don't forget to take the square root. A then is approximately, rounding to 3 decimals, 12.054. Okay? And this time we're looking for all the missing parts, all three things. So we've got A, now we need to find angles B and C. Okay? Now I know that angle B, knowing that A is about 12, I've got 6, 12, and 15. B has to be the biggest angle. I want to use law of sines. So knowing that I want to use law of sines just because it's easier, if you want to find B, use law of cosines, find B. That's fine. But I'm going to find angle C using law of sines here. I'm going to say sine C over little c 6 is equal to, we got to use A's here. So I'm going to say sine 50 over little a 12.054. And this is a case where I have to use the approximated value. Okay? So if I do this, I'm going to multiply both sides times 6. 6's will cancel. So sine C is equal to 6 sine 50 over 12.054. You're going to figure out what this is, take the inverse sine of it. we get that angle C is roughly 22.4 degrees. All right, angle C is roughly 22.4 degrees. Now I can find B by just adding my other two angles and subtracting from 180. 180 minus 50 degrees plus 22.4, not 7.4 degrees. And so this is going to give us 107.6 degrees. Okay? If you had actually used law of sines to find B, let me just show you. If we had said sine B over little b is 15 is equal to sine 50 over 12.054, just like we did here, only using b's instead of c's. Multiply times 15, take the inverse sine, we would have gotten that b is equal to 72.4 degrees. It is clearly not. All right? It is not 72.4. 72. We would have gotten a bigger angle for C if we had done that. The reason we got this is because if I take 180 minus 72.4, I get 107.6. Okay? So it's going to be directly across, you know, this is 72.4 is the reference angle basically for the second quadrant angle. All right? 72.4 is the reference angle. They're going to have the same values, but just positives and negatives. Okay? All right. All right. Last example here. Given AB is equal to 15, so this side is 15. B to C down here is 30. A to C is 24. Find the length of the median to the longest side. The median goes from an angle to the opposite side, to the middle of the opposite side. So about the middle of this, I'm going to approximate, is about right here. And so I'm looking for, this is my x value I'm looking for right here, the length of that line right there. Now since this is the middle, I know it's going to divide this into segments of 15 and 15. Okay? Okay, so a couple steps to do this. First step, step 1. We are going to find angle B using law of cosines. We have three sides of the triangle and we can use law of cosines. So we're going to say cosine B is equal to a squared plus c squared minus b squared over 2ac. So let's plug in our numbers. Little a is 30, 30 squared. Little c is 15, 15 squared minus 24 squared divided by 2 times 30 times 15. And that gives us 549 on top and 900 on the bottom. And we're going to inverse cosine that. So B is inverse cosine of 549 over 900, which gives us about 52.4 degrees. Okay? So B down here is 52.4 degrees. All right. Now we have a triangle here made by just using this median and the two sides here. Okay? I'm just considering this left, the whole big triangle, just the left part of it makes another triangle, and that's what we're looking at now. So step 2, we're going to find x using triangle to the left. It would also work if you want to do the triangle. Well, if we had solved for C first, we could have used the triangle to the right. Okay? All right, so now I've got two sides and the included angle. Once again, we're going to use law of cosines. We're going to say x squared is equal to 15 squared plus 15 squared minus 2 times 15 times 15 cosine 52.4 degrees. Right? And you can actually use, knowing that we're looking for that cosine of 52.4, I know it's 549 over 900, so that would actually be more accurate if we put that in. But anyway, when we do all this, we're going to get x squared is equal to 175.435, approximately, again. And then when we take square root of that, I get about 13.245. So that's the length of the median. Okay, that is it. That is law of cosines. Let me know if you have any questions, and